Good afternoon, everybody. Welcome to class today. Thank you for joining me. Thank you for joining me for class today, whether you're watching live or you're watching the recording. That's not the window we're supposed to be looking at. We need to change that up. Almost. There. All right. Not sure how that got switched around, but hey, we're good to go now. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you watching. And today we're talking about conditionals and recursion. So I'm going to talk about conditionals a little bit here. And we're going to talk about... I'm going to try to do a demo that's going to be somewhat similar to your bigger lab for this module, which is the Bing Whiz Pop Lab. So I just want to make sure that we all kind of understand everything as we are approaching this topic, because we are starting to move into the realm where things start to get a little bit more complicated, a little bit more challenging, so we want to make sure that we have these concepts in our minds as we are approaching them. So the first question that we have here is, well, what is a condition? Or what is a conditional? And so sometimes we want our programs to be able to make decisions, right? And so with our program, if we want to make a decision, we use a conditional. If you've done any kind of programming before or studied any kind of programming before, somebody else might have called it an if statement, right? Because that's basically the way that we handle a condition. And this sort of gets us back to kind of what we've been doing in previous modules with our symbolic logic, right? The propositions, the compound propositions, the truth tables, right? Because when we think about things from that perspective, we start to understand conditionals a little bit better, right? So the idea being that a condition contains a proposition, right? It contains a statement that can be evaluated as either true or false. And based on that, we're going to execute a certain amount of code. So we usually see a condition look like this, right? If condition, right? The condition in this case being a proposition. So we'd say something like, if A is less than 4, then we're going to do something, right? And A being a variable value that we just have somewhere else, right? And we see these less than, greater than. So that should look familiar to the truth tables that we did in the last module, right? So this gives us what we call a Boolean value, right? Term Boolean here. And this the term Boolean came from a mathematician by the name of George Boole, B-O-O-L-E. And essentially what George Boole postulated, his whole theory on math and the way that everything works, is that every single math equation in the world that exists can be solved by a series of truths and falses. So it can either, everything is going to be true or false, and then that will lead you to something else that could be true or false. And we have different types of conditionals that we could use here. We have a chained conditional, which is where we do if, else if, else if, else, right? We can do as many of them as we want. In that case, if we were to kind of draw a structure for what that would look like, it would look something like this, right? We'd start out with some condition, and we'd have a whole bunch of different paths here for our program to follow. If we were to nest a condition, then that's going to be an if statement with another if statement inside of it. And so if we were to look at that, right, if we were to go into, say, a replet here, so let's pull up a replet. Let's start out with our shebang statement, which is hash bang /USR /BIN /ENV Python 3. And I'm also going to add another line of code here. And your module talks about this line of code. But we call it a main gate. Right? And I have a whole special slideshow presentation about the main gate. It talks about the main gate, but I think I do the same thing in the module if I remember correctly. But the main gate basically just separates our functions from the code that's being executed. So if I choose to do something in a different file, for example, then I can hide the execution behind a main gate so it won't run. Right, so it might be interesting to do things in different files for the purposes of this project or for this demonstration. So here in my side panel, I'm going to click the new file button, and I'm going to call this chained.py, right, for our chained conditionals. So now I have chained.py here, and I can write code in this file, and we can import this code into another file. So let's write a shebang statement in here. /bang/usr/bin/env python 3. And let's create ourselves a function. We'll call this function chained condition. Right, and we'll give ourselves a parameter here. What kind of parameter do we want? Let's just say n for number. Right, and so we want to be able to take this condition and say, well, if this is true, then do this one thing. Or if this other thing is true, let's do this other thing. Or if all these other things are true, let's do this third thing. Right, so we would say something like if n is less than 0. Right, if n is less than 0. So that means if n's less than 0, that means it's going to be a negative number, right? And so notice here at the end of our if statement, right, we have that colon there. And if we have a colon at the end of a statement, we've talked about that before when we talked about functions, that means that there is something that belongs to that statement. Right, so if I hit enter here, we see that it automatically tabs me underneath this if condition. Right, so if we were to draw some lines here, right, we'd see that we have one tab space for our defined function here, because that function has colons at the end of it. And now for the lines of code that are underneath this if statement, we're going to tab in once more, because this if statement has code that belongs to it, because we have this colon here. Right, so colon here for the pink, that's one tab. And then for the green, that's another tab, right? Because we'll have code that belongs to this if statement, and the if statement belongs to the function. And so we'll just have it print out that this number is negative. Right, so if it's less than 0, the number is negative. So we'll just have our program print out the number as negative. So in this case, this is only going to happen, right? This printing this number as negative is only going to happen if the number is less than 0, right? So if we call this function in this program, right, the way we were doing previously, when we just say chained condition, and we give it a negative number, like say -5. Now, since we are using a different file here, we do have to run this program a little bit differently. So instead of pressing run here, I'm going to go to the shell, and I'm just going to type the words Python and then the name of the file. So that's Python space chained.py. And it's going to tell me this number is negative, right? Because that's the results of this chained condition here. Now, if I were to change that value, right, and it were to not meet that condition that we've defined there on line 4, Let's run that now. And I would run Python chained.py. We'd see it does absolutely nothing. Right? Because this condition that we see defined here on line 4 is false now, right? Because it's not less than 0, it is greater than 0. So I might want to write an elif condition for that. Elif stands for else if. So else if in the number is greater than 0, we can print this number is positive. Right, so we can say this number is positive. And so now if we run this file now, we get this number is positive because the number that we have in our parameter in our function invocation here is a positive number. So we have one if statement that applies to every number from -1 to -infinity, one elif or else if statement that applies from numbers 1 to infinity. So there is one more condition that could happen here, but we can cover it in an else statement. Right? When we use an else statement, basically all we're saying is any other condition or every other condition, everything else. Right? If it's something that doesn't fit this condition or this condition, then it gets caught by the else condition. Now, our logic here dictates that if it's not positive or it's not negative, it's probably 0. Right, so now if we were to change this number to 0, right, it's not positive, it's not negative because it's not less than 0 or it's not greater than 0. Right, remember that a value is not greater than or equal to itself, it is only equal to itself. So I can run Python chain.py here. And we get that this number is 0. So let's say I want to bring this file here into my main file. Right, well, the first thing I can do is, and we've kind of looked at it, I believe, in some of the stuff that we did last week, is I can import this file. I can import chained, which is just the name of the file, and since it is in the same file directory as main.py, I don't have to do anything else with it. I can just import chained, and I can import it as something. And that as is an alias, so that when I refer to it in the file main.py, I can refer to it as its alias instead of by its whole long name. So in this case, I can import chained as, say, C. Right, so now I have this chain.py file imported into our main.py, which means that now it could work if we press our run button, because it's in main.py. Remember that run button only works for specifically the main.py file. So if I wanted to call this function that's in this chain condition in our chain.py file, I would first put its alias for the import, which here is C. If I don't have that alias there, I can just use the whole name chained. Right, but I don't like to, I don't typically like to use the whole long names for a module that I'm importing. I just like to use the short alias that I define for it. So C dot chained condition, right? I believe is what we called it. We'll go over here and look. Yep, chained condition, and we will put our parentheses. We know something's a function when we see our parentheses after it, and we'll put a value in it. And so then when we run this, we see this number is 0, this number is positive. Well, now wait a minute. All I have here in this file is this c.chainCondition10, right? That should just tell me that it's positive, not that it's 0. And the reason that it's telling me that it is 0 is because of this function invocation right here, which is in our chain.py file. And this is why we use the main gate. So the main gate is just a line of code that says if name equals equals in quotes underscore underscore main underscore underscore. So we see here if underscore underscore name underscore underscore equals equals in quotes underscore underscore main underscore underscore. This is the main gate. And so since that has a colon at the end of it, that means it has statements that belong to it. So if I tab that over, that means that this function call here in chain.py is only accessible if the file I'm running is the file that has that in it, right? Python has a special sort of naming system, right? When we see the name of a file and we see underscore underscore main underscore underscore, we might be confused about that because main.py, right, is named main. But this name main here is special. And when we see main written like this, it just means whatever file is being run. So if I'm running main.py, the main file for that is main.py. But if I'm running chain.py, then the main file for that is chain.py. It's just whatever file that is being run. Right? That way, if I'm running main.py, since this function call here is locked behind the main gate, this is not chain.py is not the file being run. Main.py is the file that's being run. So it won't execute that this number is 0. It'll only execute this number is positive. I could also do that same thing here and say if hunt name is main, just like that. Make sure I tab that over because it is a condition statement with a colon at the end, so it has to have something that belongs to it. And so it's still going to work just the same, right? Number is positive. And so the reason why we do this is so we can have code files that we could use across multiple different programs, right? Like if I have one code file that I've written a lot of really good functions for, then I can reuse those functions in other programs if I just lock the execution of those functions in that program behind the main gate. So what you'll see is you'll see situations like this, right, where I have the whole function up here above the main gate. That way it's not locked away. That way other files can still access it. But anything that I am running, any function calls, or any special variables or any inputs or anything like that that you're taking from a user, goes behind the main gate. That way it only gets executed if this particular file is the one that's being executed. And so I will be looking for this line of code with this sort of structure in all of your programs from this point forward. And so this is an example of a chained condition. Right, let's do an example of a nested condition. I'll do it in its own file as well. We'll call that nested.py. And I've had some students in the seeded class who've kind of taken this on, you know, the idea of doing multiple files here, so that they're actually doing all of their labs in one replit and sending me the different files with different executions in them, which is pretty cool. But a nested condition in that sort of way starts out with one branch, and then if this one branch is true or if this one branch is false, I add another if statement into there. Now this is where things get real confusing, right? Because we're going to have if statements inside of if statements inside of functions. Right, so we want to make sure that we're being careful with our indentation. Right, this is where careful indentation is going to help us out a lot. Just paying attention to what we're doing, making sure that we have one indentation and that thing for each element that some other piece of code belongs to. So if it belongs to 4 other statements, you would do 4 indentations for that line. And just making sure everything is there. Right, so I'm going to write my shebang here, hashbang /usr /bin /env python 3. And let's write a function. We'll call it nested condition. And we'll put a value n here as well. So the value n here is going to be my nested condition. And in this case, we're just going to say, well, if n is greater than 0, right? Just like we did with the linear condition or the chain condition, right? We're taking the value n into our function. We're going to say if n is greater than 0. Well, we know if n is greater than 0, then it is positive, right? So we can print the number is positive. Well, what if we wanted to check to see if the number was even or odd? We know it's positive. How do we check to see if the number is even or odd? Well, I could put another if statement here, and I could say if n modulo 2 equals 0. And we talked about modulo in, I think, maybe module 1 or module 2. I don't quite remember. Right, the arithmetic operator of a modulo, which returns to us a modulus. And we said that that's just the division of, or the remainder of a division problem, I should say. I almost said the division of a remainder problem. But it's the remainder of a division problem. So if we take a number, we divide it by 2, and there is no remainder, that means that's even. Right? So I can print this number is even. So what's gonna happen here is it's going to check if n is greater than 0 first, right? Because we have one indentation here showing that this if statement belongs to this function declaration or this function definition. So we've got one for that and one for that and one for that. Right? If we look at our green lines, one indentation for each line that belongs to the function. Well, now we have this if statement. This if statement has a colon at the end of it. That means that it has lines that belong to it. So this print statement belongs to it. This if statement belongs to it. And we're going in a little bit. But now we have another if statement here. So I can take, let's make this one orange. We can see this last code belongs to, this last print line belongs to this if statement. So this last line is indented 3 times because it belongs to this if statement here on line 6, which belongs to the if statement on line 4, which belongs to the function. Right, so what this means is that we're going to check this code here. If and only if n is greater than 0, we're going to do any of the rest of this stuff. Right, so if n is greater than 0, we're going to check to see if the number is positive, or we're going to say that the number is positive, and then we're going to check it again to see if it's even. So we could say something like else print the number is odd, and let's just kind of standardize that a little bit. And so we can see if we look at our indentation levels here, the if statement on line 6 matches up with the else statement on line 8. So they're a part of the same if and else block. And if I wanted to say the number is negative, I could add an elif n is less than 0, right? And we can see that one is on the same indentation level as the if statement on line 4. And then we could basically just take this code here and we can copy it. Right? And just make the changes that we need to make. So if I copy all that code, throw it in there, right? The only difference is that I wouldn't say that this number is positive anymore because it wouldn't be. This number is negative. And the even and odd still works, right? We can do the dividing with the value 2. Right, so the only other thing would be our else condition. We can see that it matches up with the if on line 4 and the elif on line 10, which would allow us to print the number is 0. Right, so we can see, as you could probably tell, right, we've got a chain condition with a nested condition inside of it where we're checking something else. It looks, it's really got a really jagged edge here on the left-hand side from all the indentation and unindentation we've been doing to make sure that everything has the right level of indent, that it belongs to the right statements. So you can tell here why it's super important that we are paying attention to where our indentation is here. So we'll add our main gate here. And we'll say if __ name equals main. We'll run the nested condition and we'll throw a value in here. And we could even, since we did this as a function, we could run it multiple times. Nested condition 0, nested condition -5. Right, so now we have one that'll be positive and even, one that'll be 0, and one that'll be negative and odd. So if I run this in the shell, right, by executing, and let's clear out this shell, just to clear things up here. We execute python nested.py. We can see those function invocations called, and we get positive and even, which is for this function call here on line 20. We get 0, which is for the function call on line 21. And we get negative and odd, which is for the function call on line 22. Right, so now we have an example here of a nested conditional alongside of our example of a chained conditional. And I can chain this, by the way, just by the by, I can chain this with as many elifs as I want to add to this. I can just add them forever. Although we don't really want to do too much, right? If you're finding yourself adding a lot of elif statements, you might want to reconsider how the logic of your program works. Same thing for nested conditions. If you find yourself getting too deep, maybe more than 2 or 3 layers deep in nested conditions, you might want to rethink how your logic of that program works. And think about is there a way that I could lay this out to where I could be doing something different with it? Right, so if we go back to our slide deck, we can see, okay, we've seen our examples of our conditions and our nested conditions and our chained conditions. We've also talked about Boolean expressions, right, which we'll talk more about Boolean expressions in the next module. We'll get a little bit deeper into them. But a Boolean expression, in module 1, we talked about the idea of a proposition. Basically a statement that can be evaluated as either being true or false. It's not ambiguous. There's no gray areas, right? It just either is true or it is false. And that's what our Boolean expression is. So we usually take something like an equals operator, which is our equals comparative operator. And when we use a comparative operator, we see we use 2 equals signs, right? It's equals equals. And so a key thing to note there is that equals equals in programming stands for comparison. And basically when you see equals equals, what's happening is you're asking the question, does this equal this? And in response, you get a value that's either true or false. Conversely, like when we create a variable, if we just say like a equals 7, then we are just basically saying that exact same thing, right? We're just saying that A is 7. A equals 7. But if we see A equals 7, what we're doing is we're asking the question, does A equal 7? If it does, then that's true. If it doesn't, then it's false. So that resolves to that Boolean value. And so equals is one of our relational operators. You've seen these relational operators before, right? Because we did that truth table thing last week. So we see not equal to, greater than, less than, greater than or equal to, and less than or equal to. And so all of these are comparisons against two values, whether it's equal to, not equal to, greater than, less than, greater than or equal to, or less than or equal. Now we could also add logical operators to this. And basically these are the words and, or, and not. And, or, and not. So if I want to basically make compound comparisons, right, which is what we talked about last week, where I have two propositions, and I can take these two propositions and I can put them together. If I have an and in between them, then that means both of them have to be true. Right? Both condition A and condition B have to be true for a statement that is put together with the word and to be true. If I use the word or, and if I say statement A or statement B, or proposition A or statement or proposition B, then that means either one or the other can be true. And if I use not, then that is the inverse. Right? When we talked about it in terms of compound propositions, we talked about the idea of a negation. Right? And that's basically just saying that not this. Right? So if I say not A is greater than 5, and A isn't greater than 5, that means A is greater than 5 is false. And so not A is greater than 5 would actually be true, because we just take whatever that statement would have evaluated to normally and flip it. All right, and make it into something that would be the inverse. And so what we're going to do here is I'm going to use this problem here. And we're going to determine if something is a leap year. But what I want to do is I want to take it a step further. And I want to use recursion for it. So we'll start out by... And so this will kind of help us understand our Bing Whiz Pop. Right? And so that's what I want to do here, because we have these sort of issues here, right? So our determining a leap year here is similar to our Bing Whiz Pop program, right? Because I have multiple different steps in this algorithm here to where I need to check to see if multiple different things are true. And then if I want to do it recursively, then I can just do it for multiple years within a function. Right? So let's do this for 1 year. Right? And then we will change this to be recursive and handle multiple years. Right, so I'm going to create myself a new file here. New file, we'll call it leap_year.py. Leapyear.py. Right, so we will add our shebang, hashbang, /usr/bin/env Python 3. And we're just going to follow this algorithm here, and I'll just keep it small here so we can drag it back and forth. Right, so if the year is evenly divisible by 4, go to step 2. Otherwise, go to step 5. So if it's evenly divisible by 4, we're going to check to see if it's evenly divisible by 100. If it's not evenly divisible by 4, we're going to go to step 5, which means it's not a leap year. So for that, let's write a function, right? We'll define a function. We'll call it find leap year. We'll bring in some year value y. And so we'll say if y modulo 4 is 0, then we're going to go to step 2 here to determine whether or not it's evenly divisible by 100. For now, I'm going to write the word pass here, right? And pass in Python is just placeholder text, right? So if I want to write something and then come back to it later, I can just put the word pass in there and Python won't yell at me. So in this case, I can add an else statement here to go with this if statement and just print not a leap year, right? Because that's what we're saying is happening, right? We're saying if the year is divisible by 4, go to step 2. If otherwise, meaning if it's not divisible by 4, we go to step 5. So step 5 is not a leap, right? So if this is not true, where it is not divisible by 4, we do the else, because that's all other things, meaning it's not a leap year. So now we can replace this pass statement with the next condition, which is if the year is evenly divisible by 100, go to step 3. So we can say, okay, well, if y modulo 100 equals 0. So in this case, we have this nested condition here, right? And that means if y is evenly divisible by 4 and y is evenly divisible by 100, we'll go ahead and put a pass statement here. And we'll have an else that goes along with that, right? And we're actually going to need a pass statement here for that. Because in this case, it is going to go to step 4, right? So if it is evenly divisible by 100, we'll go to step 3 here. So if it's both of these, then we need to add another condition in here. Otherwise, so if it's evenly divisible by 4, but not evenly divisible by 100, we can say that it is a leap year. So we can print leap year. Right, so otherwise, right, the last thing to do, we have to, if it is divisible by 4 and it is divisible by 100, then we have to check to see if it's divisible by 400, because it is only a leap year if it is also divisible by 400. So we want to say if y modulo 400 equals 0, then we can print leap year. Else, we print not a leap year. Right, so we can simplify this logic a little bit, right? Like that's one of the things, those are some of the things that we can do. Because we could start to look at these things and we can see like, oh, well, if this is true, so we're saying basically if this is true and this is true, then we need to check this. So what if this is true and this is true? Well, if both of those are true, then we need to check this. But if one of those is not true, then we're going to print that if the second one is not true, then we're going to print not a leap year. Okay, so we can check these two individually, right? Because these have conflicting outputs. But if it's divisible by 4, divisible by 100, and divisible by 400, then it is a leap year. So I can add an and statement here. and add y modulo 400 equals 0, right? Since both of those have to be true in order for it to be a leap year, and then I can get rid of this other statement. And pull this one back. Right, because otherwise, if it is divisible by 4, but not divisible by both of these, then it is a leap year, right? So then I will pull this one back to be in line with that one, right? Because if it's divisible by 4, the logic's, this is where we're getting into that example. You got to pay attention. If it's divisible by 4, but not divisible by both of these, it is a leap year. I'm going to back up because I've confused myself because it's late on a Monday. Let me make sure I am. So if y modulo 4 is 0, we're going to print it is a leap year. Else it is going to be not a leap year. And believe it or not, I actually confused myself doing this demonstration for the seated class as well. But you can probably tell why, right? Like, it's a bit of a convoluted algorithm, right? We have to really pay attention to what we're doing here to be able to do this. And so if I were to test this, right, and we were to add a test year in here, right? So if I said something like if name is main, and we were to run this find leap year function. And let's actually take an input for this, right? And so we know that if we have a variable here, we can set the year input is enter year, right? Use our input function there. But one of the key things to remember here is that if you use the input function, it's always going to be a string. So if we need to do math or numerical evaluations with it, like we're doing here, we need to wrap it in an integer typecast here. So we need to put the int typecast function around that. So then we can do this with whatever year we enter into our input. Right? So if I do this, if I hit run here, it's going to run main.py, which is going to be our chain condition here. So I want to actually in shell type in Python leap underscore year dot py. It's going to tell me to enter a year. I'm going to enter 2024, and it's going to tell me that it is a leap year. And as we know, it is a leap year. If I enter in last year, it's going to tell me it is not a leap year. And if I enter in something like the year 2000, which is going to satisfy these top 3 conditions, it's going to tell me that it is a leap year. All right, so let me see if I can rethink that logic to where we can simplify this a little bit. If all 3 of these are true, then it's going to print leap year. Or if only this one's true, it's going to print a leap. So if I really wanted to get complicated with it, I could write it all out in one. Right? I could say like if this or this and this and this. Right, but in this case, I want to say, let's see, if this is a yes, and this is something that I like to do sometimes, right, is I like to kind of turn it around and actually draw it out, right, because that's going to help me see the patterns. So I'm going to say like, okay, so we take a year. Our first is going to be if it's divisible by 4, yes or no. If yes, we're going to do another check. If no, it is just not a leap year. Right, so if yes, we're going to do another check here. And that's if 100, y or n. If no, we're actually going to send it to leap year. Because if yes, we're going to make another check here. Y or no. If yes, we're going to send it to leap year. Or if no, we're going to send it to not a leap year. And it could just make the most sense to you to not simplify a problem like this, right? And just leave it all spelled out in their own little if statements. And if that's what makes sense to you, great. Do it that way. If it's working, that's more important than trying to be clever and compact, right? I want to make sure that is absolutely clear. Working code is way better than clever code. Like we can try to simplify this and we can try to make it shorter and we can try to do this and that. But working code is way better than clever code. So don't break your code just trying to be clever and make something smaller. All right, but if we look at this, I can see that if I follow this pattern, I get to here. Which gets me to a leap year, or no gets me to a leap year here. So I can say something like, if and so one of the things that we could look at here is like 4 times 100 is 400. So if it's divisible by 4 and it's divisible by 100, it's probably divisible by 400 unless it is less than 400. Right, which is another reason why we'd write it out this way. And really for our purposes, I think it's going to be better just to leave it like this. And, I think that's another important thing for us to kind of walk our way through is like, if we end up in that sort of situation, then so be it. Right? This works. This gives us our right answer. So be it. Right, so what I want to do is I want to be able to take this and do it for multiple years. So maybe I want to do it for all years from, say, 2000 up until the year that you put in. Right, and so for that, we're going to use recursion. And so basically a recursive problem is any problem that can be solved in relation to itself. Right, so we have the idea of a sentence or a compound sentence just being 2 sentences with the word and between them. So in defining the term compound sentence, you're using sentence, which is a part of the term compound sentence. So if you don't really know what a sentence is, understanding what a compound sentence is becomes a little tricky. 2 mirrors facing one another, basically anything that kind of references itself. Right, so anything that can be written recursively can also be written non-recursively, which is to say iteratively, which when we get into the next module and talk about while loops, that's when we get into the concept of iteration, and we get to that point. The equivalence does not say that it's as easy to do one or the other, or that it is as correct to do one or the other, right? Like in most situations, especially where we're at, I want you to use whatever the easier one is that makes the most sense to you. Right, but there are some problems for efficiency's sake where we would use one over the other. And so when we're using a recursive function, we need to remember the 3 laws of recursion. One is that there must be a base case. In this situation, when we're talking about a base case, we're talking about a condition. Right? We're talking about a condition, and that is a path through which the code does not call the function again. So basically, we're talking about a condition that starts out true and at some point becomes false. So there must be a recursive case, which is in our function, which is a line of code in the function that calls the function from within the function. Right? So like when we look at some of the stuff we've been doing, right? Like if we look here, this is a function call. But that is not in the function, that's outside of the function. A recursive function call is going to belong to this function. So that when it gets to that point, it's going to say, oh, yeah, I know that function. That's the function we're in. I'm just going to jump back up to the top of this function and run it again. But the other problem is that I need to move the problem toward the base case. So I need to take some value, move it toward the upper end or the lower end, whatever the case may be, of the value in the condition to break the condition. And then if I can do that, then at some point, the condition will stop running. And I will be able to stop the loop, right? Because if we don't stop the loop, if we don't do that, we'll have an infinite loop. Code will be broken. It'll be a bad day. Right, so let's make this recursive real quick, and then we'll show you a couple other examples. Or actually, we probably won't show you a couple other examples just because of time, although I think there are some examples in the module to look at. So basically what I want to do here is I want to have a base case. So I'm going to go in here and add another condition. Right? And I'm going to say if some new value, which is going to be called S for start, is less than or equal to Y. Right, and so we're also going to put this value S up here as a parameter. So now we have start and Y is going to be our ending value. Now since we added this if condition here, we need to come in, because that's another statement with code that belongs to it, we need to come in and just tab everything over one more from its current location. So just one more tab from its current location. And at the end here, it's going to be in alignment with this if statement on line 5, because it's still going to belong to this if statement on line 4. Right, so I want to make sure that it is indented one over from the if statement that's on line 4. I'm going to call find leap year. My Y value is going to stay the same because that's going to be the year I count up to. But that S value is going to change and it's going to increment. So I'm going to say S plus 1. Right, so that way, eventually, if I keep adding 1 to S every time it recurses, eventually, I'm going to get to a point where the S value is bigger than the Y value. And in this case, what we're going to be doing here is the S value is what's going to be checked. Right? So if I make these into print F statement and just do something like a S colon like that in all of them. So print an F statement here, having F before that first quote. I think we talked about that before. Allows me to do a formatted print. So I can just copy that and put it in all of them. So then we can see the example here of what we're doing. Right, so now if we clear this out and we run this, we're going to run leap year dot, we're going to say Python leap year.py. It's going to tell us a year. Now we've got a problem here because we didn't define a value down here. So what we could do is we could Control C to stop this. And we could just always define this as say the year 2000. So we could say S equals 2000, in which case what we probably want to do here is switch around these values, y, comma. Right, that way our year here in our initial function invocation is going to be the first thing. So we'd also want to switch them around here, y, comma, s plus 1. So now S is going to start out as 2000. We don't have to redefine it here because we've set it here as a permanent value. So it's always going to start as 2000. Y is going to be our upper limit, however many years we want to go through. So let's run Python leap underscore year.py. Let's say we want to check every year between now and 2050. To see what is a leap year and what is not. And we tell it to go. Right, and so we see here every year between now and something's broken here. It's because we kept y values in here, but we're not checking y anymore, we're checking s. So let's change those to s's. That was a little oversight there. So we'll Python leap underscore year dot py. Enter a year, we'll go to 2050. And now we see every year that is a leap year or not a leap year between the year 2000 and the year 2050. Right, and whatever that value is that we get in S here, it's checked in our algorithm, and it keeps going until it equals the value that we enter in as y. And so we could even do this as a super big number. We could do this as a way bigger number, right? So I could say Python leap underscore year dot py from now to the year, or from the year 2000 to the year 3000. And there it is. Right, there's our value. And we can see our values increment up there, and it's just running them through and checking them for different things. I did hit a recursion depth limit here, which is something that's built into Python. If you hit that depth limit, it just means you can't do anymore. You hit the wall. Right? It's not something that you did wrong. You just looped it through too much. So if I wanted to call this function in our main.py file, I need to import it. So I'm going to import leap underscore year as ly. And so now I can run. I can basically run exactly what I ran behind the main gate here in the main gate in main, like so. Because now it's going to be ly.leap year. Because that's the name of the alias that we gave the file when we imported it. So now instead of having to type out Python leap underscore year.py, I can just press the run button, enter the year. Let's say it's 2250. and I get whether or not every year is a leap year between the year 2000 and the year 2250. And we can do some adjustments on that as well. So that is our hour. So that is where we will stop for today. If anybody's got any questions, you can throw them in the chat. You can send them via Teams. You can send them via email. I am monitoring all of these things right now. So if you have any questions, you can send those in to me at this time. I'll be sending out the recording along with this demo file to you all as soon as possible. So we'll just hold here for a moment just in case anybody has any questions. Since I'm not really seeing anything come in, I think I waited long enough to outpace the stream delay here. I'll give it just a couple more seconds just to make sure. But while we're kind of waiting on that, I will say that if you're watching the recording and you have any questions, please send me an email or a Teams message to let me know, and I will answer your questions to the best of my ability. But from the looks of it, that's all that we've got for today. Thank you all for watching, and we'll see you next time.